All right. A little bit of vocabulary that we have to take care of today. I'll try and express it in many different ways, but I'm guessing you've heard amplitude before, or an abbreviation of that word I know you've heard before. Amp is probably the abbreviation that you had. It's really an amplifier is what that is for, but it means pretty much the same thing. An amplifier obviously does what for you? Enhances, it creates it normally louder is what the amplifier does for you. And believe it or not, that actually is very similar to the relationship of what happens here. But really what we're going to look at it as is you are going to look at it that way, but it's also the height or the depth of the graph in relation to the middle. So basically how tall or how deep that particular graph happens to go. For example, currently, if you were to take a look at your sine graph, it does something similar to that, correct? So what's the amplitude of that? Again, it's how high or how low it goes. Basically, it's just that distance. Do you agree that distance is 1? And if I talk about that as a distance, it is just 1, correct? From the middle. Do you understand what I mean by middle now then? And so the amplitude of that actually is 1. So you notice down here we've got y equals, there's this a out in front. So is it possible for me to put a number there then? For example, if I were to put a 4 out in front of sine, do you think that's going to change the graph a little bit? Yeah. Do you think if I put maybe a 1/2 in front, is that going to change the graph? Yeah, considerably. And I think I might have it down here, I'm not sure. Whoa, easy. Nope, guess not. So basically, to get amplitude, all you have to do is take the absolute value of that a value that's out front. For example, I could put a -5 out front, but the amplitude will never be considered a -5 because it is really like a distance. So we will just say that it's a +5. Is that negative going to affect your graph? Yes, it is. And based on stuff we've done earlier this year, you should know what that negative is going to do to your graph. It will reflect it. Okay, just like it did earlier. And it's the nice thing is it's the same over here. No big deal. It doesn't matter if it's sine or cosine. You just take the absolute value of whatever number is out there. Okay? Basically what happens is if there is a 4 out front, it's going to go 4 times higher and 4 times lower. It's not really going to change where it hits. If there's just a 4 there, it's just going to be 4 times higher and 4 times lower. And if you look at this, because believe it or not, sine and cosine actually do get related to sound quite a bit and music. It's harmonic. And so basically, if you do have it, the black one there, that's going to be 4 times louder than the red one. Because you've probably seen sound waves before. The taller they go and the lower they go, the louder it is. Okay, so the black one is obviously then 4 times louder than that one, if it was 4. So let's just determine the amplitude of these here. Well, letter A, again, where was that letter? It was out front, correct? Did I say anything about numbers anywhere else? Nope, all we're talking about here is amplitude, and it's the number out front that's attached to the trig. So for letter A, the amplitude is 3. So based on the cosine graph you know, this one would be, you could say, 3 times louder, or it would be 3 times taller, 3 times lower. Okay. Letter B, the amplitude is 2. Very good, because you have to take the absolute value of that number, remember. Because we are kind of talking about a distance. Well, what do you do for C? Do you multiply the 5 and the 6 and make it 30? Or, yeah, just look at the 5. I never said anything about these numbers yet. All I said was look out front. So again, the amplitude is 5. Again, could it be, say, a 4th? Yeah. So in other words, it would be quieter or not as tall. Okay. So how many trig functions do we have now? How many total? We got more than that. How many total trig functions do we know? We know 6 trig functions, right? How many have we talked about when talking about amplitude? Only 2. We only talked about sine and cosine, right? So which ones have we not talked about then? Let's just kind of list them. We haven't talked about, yeah, we didn't talk about secant. I heard somebody say tangent. We didn't talk about that one either. We didn't talk about cotangent. I think I heard somebody say cosecant. You're right. Those are the 4 we didn't talk about. Now here's maybe a more important question. Yeah, they are the 4 I didn't talk about when we talked about amplitude, But why? Okay. Yeah, take a look at those 4 graphs. Do they look like sine and cosine where you can just make it taller and make it deeper? No. For example, tangent kind of does this. What do you do to that to make it louder? What do you do to that? What do you do to cotangent to make it louder? What about this one? What do you do to those to make that louder? There's nothing you can do. So what that means, if I ever ask you a question like this to tell me the amplitude of that, if I ask you that and you think I'm going to, if I ask you, you can either say no solution or not applicable is actually what NA stands for. It doesn't apply, or some people like to say no amplitude. Either way works in this case, because you can't measure it. Okay. Undefined, sure. Okay. Make sure that you know if I ask you any of these 4 that I haven't read down here, no amplitude is measurable. Okay. Only sine and cosine. Everybody good with that? So any questions on amplitude before we go to the next one? Basically just how tall and how far down. That's about it. Period. Somebody, was it this class or the other class that used that word? I think somebody used it the other day in class. The number of degrees, or you could say the amount in radians if you want, but most of us prefer degrees. The number of degrees needed for the graph to begin repeating. And when you graphed those by hand, did all 6 of them eventually start repeating? Or go back to where they started, basically, in a way. Yeah, very symmetrical, right? Because it's based off of the unit circle. Okay. And what I want you to do right now, and I'm going to pause this for a second, is actually look at your graphs, look at sine, cosine, and tangent, and see if you can figure out what is the period. How long until it starts, basically gets back to where it started? Because sine does this, right? How long until it kind of just started over doing the same thing? How long did it take? Same thing for tangent, give it a shot. All right. I'll be honest, I wasn't exactly hiding the answers to those questions. Yeah, they're down at the bottom. But for sine, here's how I look at it. It starts here, goes up, comes back down, and then starts over again, correct? How long does it take to do that? It takes 360 degrees before sine starts over, correct? So, and does it really matter where you start? Like, could I start right here and then go? Would it still take 360 degrees before it started over? Yeah, it doesn't matter where you start. How about cosine? It's very similar. Cosine, if you're like this, goes, how long does that one take? Yep, 360 again. Now, tangent, well, where are your asymptotes for tangent? If you take a look. Where do they start? Where's the first one, say? At 90, so how are we going to do this? There we go, like that. So here's 360, here's 180. So right here you're saying is a asymptote for tangent. And then over here's one as well, right? So you do that, and then you do that. Well, how often does it start over? For in other words, if I started here, where is the next time it's coming up to that is at 180, correct? Or what some people do with any of them that have asymptotes, well, not any of them that have asymptotes, but they kind of look at the asymptotes to find out, well, how until it starts again. So this one is 180. Now, those are the ones that we're kind of going to focus on for right now. But basically, to determine the period for other functions, notice where this, now they chose K. I personally don't really care what letter they put there, but notice where it is. Do you see how it's right in front of the angle? Is it out front here like the amplitude was? No. Did we already have a problem that had a number on the angle? Yeah, but we asked about amplitude, so we didn't worry about 6, correct? And so I'm going to teach this one again several different ways because I think teaching amplitude with how loud something is helpful. So this one right here basically says whatever that number is, just take 360 and divide by it. Why 360? Because sine's normal period is 360. Cosine, you take 360, divide by that number. Why 360? Because cosine's normal period is 360. So then here you notice, why is that one 180? Because the normal period's 180. and you just divide by whatever that number is. I think once we do one, maybe I'll show you something. We'll see. All right, so determine the period for the following. All right, here's how I like to look at it. For sine, what is the normal period? 360. We know that we are to divide by whatever that number is, correct? So divide by 4. So my new period is 90. And I'm going to take a second and explain what that means, if you don't mind. Do you agree that's regular sine? Right? Here's how I look at it. I think of period of how long it's going to take me to hear the song once. I relate this to music. Did the whole song complete? Did it, and then it's going to begin again, right? How long? It's on repeat. Well, now I'm going to hear the song 4 times in the same amount of space on the graph. So in other words, it's going to do once, 2 times. I think I messed that up. But I got close. I think I messed that up somewhere along the way. But I'm going to hear the song 4 times. So it's almost like you took that record player and turned up the speed. So it kind of sounded like the Chipmunks. All right? You heard the song 4 times in the same amount of space. Okay? That's how I look at it. So if you heard the song 4 times in 360, how long did it take to hear it once? 90. See how that all works out? Some people like the formula, some people like the music reference. Depends on how you look at it. So how about for cosine? What is the normal period? 360. So I would normally hear the song just once in 360, right? Now I'm going to hear it twice, so how long is it going to take to hear it once? Only 180 degrees. Okay. How about this one? Ah, very good. You know what some people do? They take 360 and divide by 3. Are you supposed to do that? No. That 3 deals with what? Amplitude, not this. What number is really understood to be there then? Oh, 1. So have I affected period at all? No, it's just 360. Could you say 360 divided by 1? Sure. Okay. Tangent. Ah, original is 180. Very good. Divided by 2 is 90. Okay. Now, this last one looks considerably different. The x is kind of replaced theta. If you really want to see a theta in there, just kind of, there you go, theta. Have I told you how to do anything with something like that? No? Have I taught you how to deal with that? Yeah, that's amplitude. So I have. Good question. All right. I'm going to strongly recommend that if you ever get a problem, you write them the way that you see them right now. I'm going to show you the other way this one could be written and show you how to fix it if it's not. Writing it this way is going to save you a whole lot of time. The way this is written right now is the way you want it, because this is the number you need right there. Okay? For later on, this is the way you want it. What's normal sine? So we're just going to divide it by 3. So the period here is 120.